ये कैसे आपके
Decision. This why you'll have to mute the StreamYard का site tab राइट क्लिक करके म्यूट इन केस अगर म्यूट नहीं किया है तो या कर देता हूँ मोबाइल पे से आई एम अनेबल टू टैग इवेंट्स वीसी या फिर वो जॉइन वाला जो लिंक आता है वीसी का लिंक दैट यू कैन पुट यू डू डीसी मॉड वन सेक डीसी मॉडरेटर पे क्या चेक कर बोला मैंने अभी जस्ट डिलीट कर दिया रुक गया मैंने बस लिखा था हे फोक्स वी आर स्टार्टिंग द सेशन start joining so and so VC. But you can put the VC file link. One sec. Let me do that. Invite. Mm, yeah, community pin.
Hello, am I audible? Hello, am I audible?
Yes, yes, you're audible.
Okay, I guess 10 minutes have passed. We should start now. What do you say?
Yeah, we can start. And we'll share the recording later in case anyone is missed.
Yeah, that's great. Okay, let me just share the screen. Okay, okay, here we are. Okay, so today is our final day of the 3-day workshop, and we'll be building a shell from scratch. Uh, Yesterday we covered various functions associated with the POSIX API. I also shared a resource of the POSIX IEEE standard documentations where the most important part that I specified was the header section where we can we can read about various header files and the data types they store, the functions they store, as well as the structures or uh, other piece of information that we can obtain. So let me just find their website. Okay, so this is the website. I will share the link again. And the thing, the shell that we'll be building today, I have um, already created an implementation of it that is hosted in the design and code, the DC shell repo that you can uh, visit. I guess Siddharth has already provided the link for his repos. So we have created this repo, and we have also provided the installation instructions. If you are using Windows, then I believe you have to use WSL to run this. So there are mainly two variants of this. There are a lot of variants, but two most popular, the Debian and the Arch variant. So the Debian variants consist of distros like Debian, Ubuntu, Linux Mint, Kali Linux, Pop OS, uh, Ubuntu, etc. So for those distros, you have to use and then Ninja, which is a build tool. We will learn about them a bit later. And for Arch-based distros like Arch, Arco, Manjaro, Garuda, Linux, Endover, I believe they will use a Pacman manager. I guess we have to add the sudo. Yeah, okay, I'll update it later. We have to add a sudo pacman -s and the package name. So we have to run these two commands and then navigate to the project folder and run cmake gninja, specify the source directory as the current directory and the build directory as build, and change directory to the build directory and and then the CMake will produce a build on Ninja file. You have to execute the Ninja file by running Ninja, which is the build tool to build an executable for us, and that executable will be the final shell that we can just run as .exe or the next executable file. So let me just quickly demonstrate it. So I'll go to this build folder. Let's zoom in a bit. This is the build folder. We'll just navigate to there. We have this build on Ninja. Always to run this to create executable out of it. We have to call Ninja. It says no work to do because we already have our executable set here. But let's say I completely remove this build directory. So this is what you'll get by default when you clone this repo. Now you have to do cmake and Ninja, who specifies the build tool. We'll be using Ninja because I think Ninja is comparatively faster than make files. We'll do cmake plus gninja and specify the source directory with the current directory because we're in the DC shell directory, we're not in the build directory, so we'll specify this directory to contain all the source code, and the build file should go in the build directory. And we'll just go to the build directory, do an ls, and you can see this build on Ninja file. So to create an executable on it, you just run Ninja, and if I do an ls now, you can see this executable file. I'll just run it, and here we are. So I can do ls. So let's say this is a working shell. You can do anything. You can navigate directories like this. You can clear the screen. You can navigate the directories. I have just add images directories. Okay, so auto completion doesn't work, and some of the features don't work. I guess it will be a task for the viewer to implement them, but uh, for a basic cell, I guess this is just enough. I will change it to tilde doesn't work. Oh, it works. And okay, so change directory documents. We have our documents listed here. Okay, so change directory tilde doesn't take us back to the /home/user directory. We have to again, work on that. Maybe this will be a task for the viewer to parse the tilde character to /home/users. This will be a task for the viewer, or we may later implement it down the line. We'll see, but this is the basic cell. You can run anything, almost anything. So if I just go and we can get any file, we can get this can get the EMRC file, and it will just display its contents. And yeah, we can pretty much do anything. We can also do something like, okay, let me just try to remove something. Yes. So I'll remove this animating donut project. This is an animating donut that I created in C a while ago. I have the repo hosted in GitHub, so it doesn't matter if it's in my local machine. I can just do okay. Okay. Trying to do it. Yeah, because removed we have used the post flag, and yeah, that's the working shell. It doesn't have highlighting and stuff, but again, we can work on this later. This is just the basic implementation. And another thing, the pipe doesn't work in here. So what is the pipe? So for this run something like neofetch, you get a standard output. And if I just do neofetch pipe lolcat, it will just run the neofetch command and take the output and pass it to this lolcat command, and lolcat allows us to use this varying set of color to display our text. Uh, so we can just get a nice effect on the neocatch command. So the output produced by neocatch is fed to the lolcat as an argument. So so piping doesn't work in the shell, and piping can be implemented later down the line. But again, this is a very basic shell. So if I just do exit, and then we'll reach the page in our standard or default fish shell. Okay, so this is what we'll be building today. It's going to be very interesting. I have the source code in here, and for yesterday's source code, I guess we created a repo today. I forgot to um, add the code. I'll edit a bit later and just see what's the required. Also, I didn't read me here. I'll link all the resources. Uh, but yeah, let's get started. Okay, so first thing, let's get out of it. Okay, so first go to make a new directory, C programming workshop, oh, project, project, and we can now start. Okay, well, we can start with the get ignored file. So we'll get init. You know what? We won't make it a git repo because I already have hosted a repo here. So that will be a mess. We won't be using git in here. So okay, so first we'll make the CMake list file to specify the configuration for CMake. And first of all, let me just give a brief overview on CMake. Just do a quick Google search and we'll go to the official website for CMake. CMake is an open source cross-platform family of tools designed to build, test, and package software. Okay, so uh, this is a cross-platform tool that allows us to, compile our C or C++ software and run it on any device. So it's not like Windows specific or Linux specific. You can use CMake with any operating system to uh, mainly create a standardized way to specify how the package is to be built. I don't really know a lot about CMake, honestly. I know enough to, uh, start a project and work on it, but I don't know much about CMake. You can, of course, read the documentation. But again, it's just a way to create a standardized project structure, specify the headers, file directory, and all that stuff. And we will be using Ninja Ninja build system, small build system. Ninja is a small build system developed by Google employee. Ninja has a focus on speed and differs from a build system in major respects. It's designed to have a simple file generated by high. Okay, so a higher level build system will be CMake. So it will generate a Ninja file, and then and the Ninja file it is very similar to a make file. And speaking of make file, let's take a quick look at the make files. Okay. A make file is a specific file containing shell commands that you can make. Okay, this will be cool. Okay, so let's just take a look at make files. Here are multiple sources. You want to compile them. The command sources kind of problem use make file because during compilation of large files you can declare them the source. Not just a listening for plugs are required. Okay, so make file is a way so that you can compile multiple files quite easily, and Ninja is a very similar build system, but it is quite faster than this. So you can see there are multiple source files, and makefile specify the target name and then the compiler name and all of the things. So CMake is a high-level build system that allows us to create this sort of makefile. So we can either create makefile or we can either create Ninja files. I prefer Ninja because of speed, and then we can um, so then we can just run this Ninja file to produce an executable compiler source code, and yeah, that's pretty much it. So let's just first create this cmake list.txt, and I'll just copy paste it because well, it's nothing conceptual. You have to just the standard specifications that you can read from the documentation. So first is the minimum version required. This just specifies the version of CMake that we'll be using, or maybe that is the minimum version that we'll need, and uh, a version higher than that will be okay. So CMake list of txt, and the case should be exactly similar because this is a special type of text file, and as you can see in the starship prompt, the logo appears denoting that we have CMake file in here. If I just open a new one and then just paste this. And next up, we will just name the project. So this is the name of the project. We don't need the quotation in here. We just uh, pass this value without quotations, and it will work. And then we have to specify the include directory. So include directories is the header directory. So we have this headers directory that stores the definition for this header files that we'll be using in our project. So we need to specify that, and we need to include this line. So basically, it defines where our headers are stored. It is the project source directory, which is the directory that will be that this file will be in, and then slash headers will be the headers, the subdirectory, the header subdirectory. So for that, we need to run headers. So just create a directory. I hope so. There we go. We have a headers directory. I just ran it every directory by running a command using the Vim way, and then we just need to add the executable files in here. So the files to be compiled while the build system runs. So first, let's only have this. We just have all of them at once. Let's create the files. So let's see. We need utility.c at some point, and we also need shell utility.ca, and we'll just go to the headers and shell utility.h, and we create heroes.h. So here we are. We have our basic project structure. Okay. This is everything set up. Okay. So first, open the main.c file and we'll get started. Okay. So while making a shell, there are three main things that we have to take care about. Three things to take care about. And number one will be starting the shell. So we may load config scripts. So this is basically like if I just go and put in a config directory and go to the fish directory, you can see this config.fish file and fish variable. This is the fish shell. As soon as it starts, load this uh, config.fish file because this is where this configuration for the fish shell store. Maybe it stores some alias like if I run ls this command set executed. My preferred way of listing directories, it provides color as well as group the directories. And I set my default editor. I set a fish greeting to nothing, and I start the starship from. So fish execute all of this as soon as we launch our uh, uh, um, launch our fish shell or the terminal. So for sake of simplicity in this project, we won't be dealing with the config files. Then the next thing that we need to care about is, of course, the execution of commands. So this is the main section that we'll be focusing on how to create a child process and then run the command in the child process or exit it if we're not successful, how to parse the strings and how to use built-in commands. So this will be the main section that we'll be working on, and we also have a third section for cleanup. So this is basically cleaning up the memory if we are uh, using functions like malloc or something like that if we access the heap memory. Okay, so these are the things to keep in mind. And okay, so let's just get started. First, let me include the header files. I'll most probably need stdio.h because I'll be using the uh, PRO as well as the okay, PRO as well as the print functions. Okay, so let's go workshop project and we'll use this terminal to build our files rather than using the new terminal that comes here. I won't be using it today. I won't be using this terminal today. I will be using a new instance, and I'll also uh, open the man page for Piero to see if anything. Okay, standard CW. We don't need something else. So this is just print an error message, and the thing that we'll be using the most is the man pages to look at the synopsis and details about the various functions. It is humanly impossible to remember everything about the functions. So we use certain references like the IE specifications and the man pages to interact with these functions to know what arguments they take and how to use them. Even they include certain examples that we can look at to understand the working of a function. So there we go. We'll need the studio file. Let me just create the main function. Start. So we we won't use argc and argv, but let us stay here and leave 0. So first up, let's do something. Let's get a username. Username. So the way to get username is the get environment variable function. Uh, Get env function searches the environment list to find our environment variable name and returns the pointer of the corresponding value. Okay, so it is used to look at our environment variables in our Unix system and find the find the thing that we find the environment variable details that we need. It stored as a string and then returns the pointer to the string or maybe the address of the first element, and then we can use that element to navigate through the screen. So if I do user, perhaps for okay. Okay. Okay, this is the default. Okay. Okay, so the the get envy function returns a pointer on null if there is no match. Okay, so it will look for the environment variable and it returns a uh, pointer to the first element or maybe, to the string, uh, uh, and then if it doesn't find the environment variable or the global variable or the whatever you want to call it, it just returns null. Okay, so first we need to access that to print our username and print a welcome message. So it will return a pointer to the first element. Basically, it will return a string. So we need to do that, and then we need to specify which environment variable. So we'll be using the user space. I can access the user environment variable in question dash user, user. We could find the editable to find the user, which is weird, but well, let it be. And then let me just define the size real quick because I don't want to use magic numbers in our code. I just want to standardize uh, variable name, or better, you can use a preprocessor to define define a value. So the preprocessor will, so whenever you use size in here, for instance, if I do char line and then do size, then it will create an array. Okay, let me just pointer. It will create an array and then of 1024 elements of the char type. So the size will get evaluated to 1024 even before the compilation process begins. That is in the pre-processing uh, phrase. And then command with arguments. And then we need to do, okay, how many maximum arguments can a command take? We have to specify it in or max and let it be 20. So this is the maximum number of arguments that a shell command could take. So max and then the first thing that we want to do even before printing the green is clearing up the shell, the existing terminal windows. We'll do 033. We will write to the standard output, and this string or this character, the string right here will clear out your screen. This is an escape sequence character slash 03, and this is the argument. So basically, this is a easy way to clear our entire screen. We can use other escape sequence characters to accomplish the same thing, but for this course I'll be using this. And then just do and then I'll just want to print a string and the nice little wink like between windows and make a new line, and for the string that will go here it will be our user. So if I now try to go okay, so let's just build. Okay, I go to the till now and run our ninja. Okay. Okay. Printf. I make this error very often. I work with Python and we use print in there, and in C it's printf, and in languages like Java it's even something more long. It's like system.out.println or something like that. So this confuses me sometimes. Okay. So next up under teaser. Okay, so the error getting is implicit declaration. Okay, maybe we forgot into the header file for this function. Yes, the standard lib.h. Oh, and there we go. It first cleared our screen and then printed this line and then exited. Of course, we have to create a loop to keep the shell running and all. But this is a strong start. So now we'll do we're just running currently. And we'll exit it if we just type the exit command. We'll see that later, but for now, I'm just running infinite looping here. And first thing that I want to do now is use this B0 B0 function. We'll need the strings.h library. The okay, so what B0 does, the B0 function erases the data in n bytes of the memory starting from the location pointed by the s, which is the first argument, by writing zero bytes containing null character to the area. Okay, so it just makes everything null in a buffer. So I can leverage this to clear our okay, so clear the arguments buffer so that everything overridden when we uh, first uh, when it is provided when we just run a new command or something. So the first pointer will be command with arguments with arguments and will be the size of what close. Okay, so everything will become null so that we don't have values that are just lying around in the buffer, and because it might interrupt the flow of our program and we might get an error. So the next thing that we want to do in the loop, now I want to go to a separate file, possibly I'll use the utils file now to, or maybe the shell utilities file to create a status line so that we can display the current directory and the user in the status line itself. So let me just open the file and I have named it utils well shell utils. I believe shell utils. So C, and real quick let me just find the header file too. So let me just find the declaration for the header file. And there we go, hash. If not that is if not defined, if we haven't defined the file, then we will define it or maybe just run it. So this is primarily to check that if we have already included our file, so that we don't mistakenly include it twice. Well, it is not a big problem if we just include it twice, but again, it will take more processing for it to take up more resources, and it's always a good practice to use it so it, that if not that is a preprocessor directive that checks if uh, this macro or this preprocessor this macro is defined or not. If it's not defined, then we'll just define it and then in this so that if so that uh, okay, so before running this and if we will also define our function and declarations and all. So this is particularly so say for instance we included the shell dot h file here and then we try to include it again then the compiler know that this macro is already defined, so we don't need to again redefine all of this, and it will save a lot of time. So that's why we use it. We won't throw an error, but it will save us a lot of time. And the function that I want to create right now is print status line. So this is the line that will appear, and then the arguments that I want to provide to it is the username and the size. We'll get to know what the size is a bit later. And save it and just yank this and let's just switch buffers. So okay, um, now let's just create this function, paste it in here. The thing that we need is the shell utils.h. And first we'll create a current working directory. We'll create a string, which is of course an array of character in C, and we'll just take the size and input. We'll use the macro, and then we will use this function for get CWD, which stands for get current working directory. We'll just do man get CWD. First, we'll include this unistd.h header file because that's where this function is defined. std.h first and okay, so get current directory takes the buffer where the directory needs to be stored and the size of the buffer. Simple as that. So, so the buffer here, of course, is CWD, and we'll do get CWD. We will store it in the buffer name CWD, and we'll just calculate the size of, and we'll just do CWD. So we use this size of, I believe I need the stdio at the file. Okay, maybe that's right, I forgot it. And well, now we'll do a if check. So on success, this function returned a pointer to the string containing the file name that is a string. And in case of get okay, on failure, this function returned null. Okay, so if it is null, then we'll just print an error. CWD will equal null and into the error. We'll just say fail to collect directory info. Pardon me if I make a typo. And then okay, exit out of our entire program as a result of this error. Well, if that's not the case, then I want to print something. That will be print and I want to use this for the username and then replace. Okay, so basically what will print is inside the square braces will print the usernames. Username will be, of course, we'll get it via the argument, and here in this uh, percentage we'll just pass the primary working directory. And, well, we're done with this function. So we'll just go here and let's first include the file. And whatever we named it, we have named it, I believe, whatever named it. I guess we named it, yeah, we named it print status line. Print status line, and it will take the user as an argument. User, and we're going to pass the size, which is the macro that we defined. Run it, or save it, and then just try to run it here. And okay, exit. Okay, maybe I have a standard library in the users to see. I sometimes forget this header files, and that causes a lot of havoc. Okay, so it just keeps on printing this directory, and it just never stops because we are not looking for inputs now, and the next thing we will be doing is looking for inputs. So I'll just take a look at the chats and see if anyone has anything to ask, and then I shall proceed with writing a function to take input from the user. Okay, so the chats is almost dead, but again, anybody who has their questions can ask now. Uh, okay, I believe no one has any questions. You can just type clear or something like that if we're good to go. Are we good to go, guys? Guys, am I audible? Are we good to go? Oh yeah, that's great. That's great. Okay. Okay. So the thing that we'll be working on is the user input. But before doing that, let me just go to our main function and just add another line. Just write. Okay, so write is used to write to a buffer or write to the. Okay, it takes a file descriptor as an argument, and also the string, and also the size. Okay, write to a file descriptor, and we'll use this function to just give you just you provide this character, um, provide this character indicating that it's a prompt. So we'll just do that, and we'll pass it to the standard output. So the standard output and standard input. Let's define those macros first. Standard input, and it will be one. Standard output, which will be okay. So the standard output is 1. Standard input is 0. That's Now let's do it in standard uh, output and right character. And we already know the size is 2 because well it's 2 characters. It's this prompt character and the space, right? So okay, so the next thing that we will be working on is creating this uh, uh, read user input file. So go to this. I think it's in the. I think I'll put it in the. Uh, let's put it in the shell users storage. We can write we can write the function definition in here. Read user input and can this of course take this to the buffer the buffer that will be storing our data in as the input, and then the input file descriptor itself and the size of the input buffer, and just yank it and shell user.h c and paste it and start writing it. Okay, so first up, let's go 15K and includes something called ring storage to clear the input buffer first. And then we use the read function. Okay. So the read function, we read the input from the standard input. So I just put the input as a file descriptor get and the buffer as the buffer and of course the size. And the next and the most important thing that we have to do is this. So I wasted almost 3 hours main because I forgot to put this line in the program, and I was just having a really bad time uh, trying to debug it. And that's this line. I'll just explain in a minute what this is and why is it useful. But trust me, I wasted 3 hours for this. Okay, so read is used to read the buffer. So B0 will just empty the buffer if there is previous data stored in. It will clear it and clear the entirety, and then it will read new data from the file descriptor that is provided. The file descriptor, of course, in this case will be the standard input, and it will store it in the buffer that we provide in here, and then we'll take the size of the buffer as an argument because it is a mandatory argument for read. And what read does by default is that it creates a new line at the end, and then when we parse the string in spaces, our last argument always has the new line character, and that's why when we just try to execute it in using the exec vp command, it just doesn't get executed, and we get command execution failure. And then finally, after a lot of um, after a long debugging session, I figured out this anomalous behavior of the read function, and then what I did is that I took the buffer, I calculated the length of the string, the that is the buffer itself, and then since the indexing starts from 0, so I subtracted a 1 and from the length, and then assigned that to the null character rather than the new line character. So this prevented the anomalous behavior, and I could read the data in an easy way. So now all I have to do is go here and type the function that we just declared. What was the name again? I forgot. Read user input, I believe. User input, and also provide the arguments. So the line, which will be the buffer, this line array that we have defined in here, and this is an this is a pointer to an array, and we'll use it later with arguments and stuff. But for now, we'll just use the line. We'll provide the standard input as the file descriptor, and we'll provide size, of course. There we go. Line, put in size, that's right. Define in the correct order. Okay, so now if we go here and do a CMake and then just okay, I forgot semicolon. Okay, I made another mistake. That's right, maybe I forgot the library. That's right, I guess I forgot the library. Here we go. We have a prompt, and well, basically it does something like describe anything here. But again, this loop never ends. Also, this prompt does nothing. But again, we have our basic prompt setup, which is definitely a progress. So the next thing will be, dividing this string into uh, parts so that we can distinguish the arguments, the flags, and the original command that is pass it to executing function so that well the execution starts. So before doing that, I want to see the threads again and see if anyone have any questions, and then we can proceed. Okay, anybody, if you can ask questions now. Okay, okay, I'll just assume that no one have questions, and I'll just move forward now with uh, parsing the string. Okay, now this function, I believe, will go in utils.c, and let me just close this utils.c and plus minus utils.h in our headers. First, we just do if not defined, let's just file of c+.h, right? So underscore utils underscore h underscore. So this is just a standard convention to write it like this, and let's define this. Again, I explained it a bit earlier, but parse inputs in the that is take the buffer and break it into pieces and in a new uh, new command data structure. So to point like pointing to, well, okay, let me just use the okay, let me just demonstrate this, and you will automatically get how it works. So let me just each and now place this here, and first we loop, so we'll use a I I value as something to do, and we'll define the chunk value and the string. Okay, so the string will be equal to the output, and then it will be the line. String, sorry. Okay, so what this function does is, let's just read the main page. The str function returns a pointer to a new string, to duplicate of the string as well. Okay, we'll just create a duplicate for the string in the memory so that we just don't manipulate the original string, and then we will do a while do a chunk, and then we'll use the string set function that is used to separate the string, and pass the string, and we'll separate it in every space, right? So we'll just separate it, and then it will return a null if it fails, or if there's nothing to separate, and else we'll just store its variable value in the chunk um, in the chunk string. Okay, so chunk, and for going to make the last one null automatically. Okay, so this will be like a pointer to a pointer, so maybe it'll point to a pointer that will list of pointer, or list pointer that will point to several other strings. So when I do cmdi, it points to the ith string in the array, or in the pointers array, and then we initialize it to the string. So it is like there should be okay, so this is like the memory, and we have like parts in here, and there is an array of pointers, and then there's a array of pointers. Okay, we have multiple strings in here. Let's say we have multiple strings in here. And then we have this pointers array. So the first pointer points to this string, the first element of this, second pointer points to the first element of this, so this points to this, and this pointer points to this index in here, and the final pointer points to this index in here. So it is like, and then we have a pointer here that points to this. So uh, it's like a tree or a hierarchical system. You can see this pointer points to the first element of this, and then each element of this points to a separate string or area in memory, and we can store the contents in there. So hopefully you get the gist. It's a bit complicated, but bear with me. When we see the use cases, we'll know how important this is. So basically, we're done with this parsing thing. Okay, there are some internet issues with you. Okay, this fine. We'll just continue. And I believe someone is recording this. Then we just parse the original string in the main function. So put the main.c, and then do just wait a second, and then do parse input string, okay, parse input string, and then the line which is the main buffer, and then this array of let's say pointers, pointer to this array of pointers, which will be like a command do it arguments, and then the maximum argument that we can give the size. And, um, okay, so we didn't use the max words. I guess we first used the for the something, but we didn't use it. Let me take care. Okay, so okay, so there, so this is like the string. This is like another string and another string, and we are creating an array of pointers where each element points to something else, right? So the first element point to this string, the second element point to this, and the third element point to this string, and then we have a main pointers. So the so always this first element will point to the command, and this latter elements will always point to the args. So when we separate this string, let's say command, let's say cmd dash h dash a. Okay, so say this is a command. So this will always be so this is the array of pointers. This is the array of pointers, and this is a string in memory. So the first pointer will always point to this first command, or the first what do you say, the first instance, and the latter will always act as an argument to the first one. So we have this pointer number one will point to CMD, the pointer number two will point to H, and pointer number three will point to A. So hopefully you get the gist. It's a bit hard to visualize until and unless you have a crystal clear concept of pointers, but bear with me. Once we just execute our code, you will know how easy actually it is. Okay, we have a problem. Okay, and if not, okay. Oh, okay. I was typing. Sorry. Not F. Okay, there we go. This is pretty much be the same, but the commands are getting divided. I just haven't print them using a for loop or something, but um, well, our code get executed and everything. It's all right. Okay. Okay. So the next step will be to execute a command. I mean, what else can it be, right? So we need to make a function so that we can execute. Referrals H, and in the shell utils H will create the execute command function. So okay, so the input strings are parsed. Then okay, so this command with arguments. So the command is the first pointer, and then the argument are the rest of the pointers that we have in our array of pointers, and then this values get assigned because of this parse input string function. And now we're going to leverage this to use it in our execute command function that will execute our command. So we'll make a few built-in commands, but before that, let's use the standard exec vp to create a new command, a new create an executable. So exec GP, okay. So the exec family of function replaces the current process image with a new process image. The function describes in the manual feature layer. Okay, so the function that will concern ourselves with is the exec DP. The function duplicates the action. So okay, so the function duplicates the actions of shell in searching for an executable file in the specified path name. Does not contain this list. That file is sought in one separated list of directories partners. The variable is indicated the path. Okay, so we have a clear description of this exec command, how this works. So exec will be searches for the program using the path from the follows. Okay, so basically this is used to uh, you know uh, find the program that we want to execute in our shell. So if I can do something man cd, oh, okay, no, and cd pitch cd, okay, yes. Okay, so which MPDR? It shows the location of the binary file in the MPDR. So when I run mkdir this program right here stored in /admin/mpdir gets executed. So we can see that there is no CD in this. There is no executor for the CD command, so we have to implement it ourselves. But for commands like okay, which rm rm is a remove command, you can say admin/rm. So each and every command that we run on the shell is an executable that is stored in this admin/ uh, whatever directory, this rm mpdir mpdir rm, and it is stored there, and we need to run it. So exec vp allows us to run all of these commands, and in case of cd we don't have such executable file. So it is upon the uh, shell developers to implement CDN. We implement it with the chdirc function. We'll take a look at it a bit later, but again, you can just look at the address of each and every terminal command that you can run. So grep, for instance, as this let's grep, which uh, man page even the man page isn't has been / man. So we can pretty much run each and every command possible in our shell, because most of these things are executable stored in our computer in most probably /sbin/ whatever uh, the command name directory, right? So so the thing that a shell handles is creating a child process to execute this uh, this command. So this command executed it gets executed as a child, uh, and also if I just do ps x, so everything got executed as a process, right? Even this ps this aux, and then the Firefox instance that I have, the Discord instance that I have, the whole studio instance that I have, which is running as a daemon, I believe, and some system d stuff. Okay, so everything got executed as a process. So we create a new process as a child process, and then use it exec command to execute this uh, execute this applications or the programs that we have that serves different purposes. So even the copy command will also have which will also have executable in this admin directory. So this is basically how the system is working. It is very much attached to the Linux philosophy of everything is a file, even our pen drives or stuff like this. So if I just go on, okay, this is the which lsblk. This is the lsblk command. This is used to the uh, drives that is connected to our device. So I will just okay, so this PL. Okay, I will fill command now. You see, I have a swap partition. I have our root partition. The partition one is for the boot, and the partition two is this partition itself. There is another swap partition. This is because I have a dual boot operating system. I have Kali Linux. I thought of trying it because I have heard quite a lot about it, and also have a partition tree for the Kali Linux like root system or whatever. So if I just go on and plug a USB stick into my machine, so let me just do it. I have a USB stick in my hand right now, and I have done it. So if I let's see the command now. You can see this SDA 29.3 GB disk right here, which is mounted. So this is so. Uh, if I just launch a file manager like Tunar, we have a 31 GB volume. Even though the ls command shows us this isn't mounted, we actually have it mounted. Or we can manually mount it if it isn't mounted, or we can just mount it in a separate place using sudo mount and the and the storage device and the location. I can do this by doing this. And now run the lsp command and it is mounted in two places. The media slash USB that I mounted right now and the default location that our computer has specified. So we can do sudo umount mm, slash run slash media slash 7c. Okay, and then now the lsbl and listen and now and it's mounted to media slash u. So if I just run our file manager now, you can see it's mounted to media slash USB. So this is the mount point. This is just where the configuration of this file will be stored. So everything in Linux is a file, even even the storage device just comes as a file. So this is something that is associated with Linux and operating system in general, and I hope I have got it right. And you guys got the gist. It's a hard concept to understand. Even the commands that we're running in our shell is a program in itself. It's a file in itself, and we need to execute it in somewhere. So the exec VP function allow us to execute those commands stored in our slash sp slash um, as whatever directory by creating a process and creating a child process um, and then executing it and then successfully exiting it. So the main function of the shell is to help us go through this process of creating the child and executing the command and then successfully destroying the child and running the command. So the next thing that I will be creating is the core part of the shell, the part that will allow us to execute all this command. So let me just quick look at the chat because now I explained something really important and I hope that okay. And we'll just take this double pointed thing and do this. We'll just yank it and go in here. Go to shell it to page. Go down here, paste it in here, and then just alright. So okay, first we need let's okay. First we need the type storage because we'll be using the fork and we'll be ID. We'll also need the fork function, so it probably requires a separate header file. Man to fork. Yeah, it requires when I believe I already have included it. Oh, sorry, I have. Uh, okay, I will need the wait file so that I wait for the parent to stop this. Yes. Wait. Okay, there we go. These are the files that I need. So first we create a child process. We'll just make, use the fork function to create a child process. Easy as that. We now have a child process running, and now if id equal to minus one, so I won't look at the main page now because I fork fails, it returns a value minus one in the PID. So PID, let's say ID. So what mean PID equal to error create child. Oh, and we of course exit our program with the error message. Then if it's the child process, else if um, ID is the child process, then we run the exec VP command. So exec VP requires something from the main page, I believe. Have you header file? No, it doesn't really the page. So exec VP. So command zero, as I already told, array of pointers is the pointer to the first string, and the pointer to the first string will always refer to the string um, which contains a command name, because the first thing we type in a shell is a command name, and then only we type the arguments. So C and D, and if it's equal to one or equal to minus one, which is an error, of course, then we'll do p error and get exit. I will return from the return return from the function itself. No, we will return. We will create child. Return from here. We won't exit the function. We just return in here and just put p error and this is a command and exit out of the process. So this exit statement will only exit as out of the child process, not the parent process. So the function will still keep on running. And I demonstrated the fork function in great detail yesterday, so I won't be covering entirety. And while this child process is being executed, the main function should do nothing, should wait, that finally return. Okay. Okay, so we created a child. We checked if the child is created successfully. If it is created successfully, we tried executing this command, executing the file for the specified command using the exec vb method, and if it returned minus one, then which means an error, we will say that we can't execute command, else we'll just keep moving on. Okay, else the parent process will wait until this child process is terminated, and then the parent process will return from the file. So I'll just run the execute here. You command and then do necessarily command with arguments. That's what I want. And get this in here. Okay, so do this. Okay, we have an error. In function parts into string. That's not what this one. Basic declaration 933 bars interesting. Are you getting this error? Okay. I believe I didn't. I deleted it. Somewhere down the line. Maybe accidentally I deleted this file and it didn't work. Okay, now this is there we go. We have a basic shell now. We can't change directory because of course CD is not a program that is defined. So if I press my username, you can execute command no such file or directory. Well, CD is not even defined yet, so we have to define CD again. Okay, so that's it. We have a command, the command line working right now. So if I just do neo caption here, let's see what happens. Okay. There we go. We can even run new caption. As a matter of fact, we can run anything in this shell. It is like a workable shell because all of the commands executed in the shell are also applications. We are just creating a child that allows us to um, this allows us to run this application while as a child process while our parent shell is still intact. We can also do this to make myself feel like the chosen one. There we go. That's great. So now we will just take a quick overview of the built-in function and then conclude our lecture. So the built-in function, it won't take time. We'll just create two built-in functions, the exit function and the change directory function, and then we'll just call it a day because well, we program the shell and it's not a small thing. It's actually quite huge achievement, I would say. So, so anybody has a doubt? You can just react with something like okay or clear or something like that so that I know that we are good to go. Are we good to go, guys? Yeah, maybe everyone should go deep into this subject, and that's great. Okay, so let me catch my breath, and then we'll just create the built-in commands, and then we'll just include it. So we don't have a lot of work left. We'll create one more function, and then well, we have a workable shell, except pipes don't work, and I will leave it as a task for the viewer to implement pipes, or maybe I will implement it later whenever I feel like implementing those things. Okay. Let me just close this. It's just a waste of memory now. 4, go to 3, we have 5. Okay, we just go to 4. A new one. Okay. So the final piece of the puzzle, the built-in command, so that we can exchange directories and have a perfect workable shell. In our users.c, we'll create this file. So this will be users.h and parse public. Built-in commands into CMD and just yank the entirety and just go down here, paste this, go here, and now first we'll define a few constants. So I want to make this file function in such a way that we can just extend it quite easily without modifying a lot of things. And for that we use switch statement. So we'll have two cases by default, and whenever we create a um, new built-in command, we can just create a new case, and who will create the new built-in command as well? The viewer, of course. You guys can do anything. You can just make your own implementation. You can just extend it and then provide a PR, or you can just collaborate on this project. And really make it uh, something that is worthy of using or something like that, right? So I'll leave it to you guys, but I'll create a basic implementation. First, how many commands do we want? Well, initially we want two. Next, the I, because we'll be using a loop. And we have the command number for the switch case. Initially, let it be 0. So, let's make a similar list of pointers. Okay, list of commands. List of commands, and we'll just create a list of commands and then the list. The first one will be the exit command, and set the specifications in here. And another one will be city, and then just create a for loop to determine this command number. It will be 1 if we want to exit, and it will be 2 if we want to execute cd. So to determine that, we'll just do for I is equal to 0, I less than number of command implement I, and then compare this strcmp, and then if the command, and the command itself from the list of command will be the first, not the argument. So we'll use the 0 and is equal to list of command, and then the I cmds and list of command the first index, and if it is equal to 0, that is it. We'll just compare this one. I hope I haven't put this one for each. I did. And then we'll do command number equal to I, whatever it is, and just break. So so as soon as we hit a command that is in this list of command list, and then we can just exit the loop and then store a command number so that we can work pass it to the compare in the switch case and do something. Switch, and then the command number, of course, and if it's case 1, then it is exiting shell command. We don't need to print anything, we just do rent /0 I believe it's 33C, that's right. It will just clear the entire screen and exit 0, it will exit that program. I believe I reached 10 building one. And this is the case one. We have a second case, and that is change directory, right? So we need to include this man ch yeah. So the directory where we want to change the where we want to change to anyway we need UNIC the h and the path. Okay. So and just go in here and start writing. So first we will change directory chdir, and it will always be the second thing, the second argument in the change directory to which will be the path we won't use. We will specify the path for the sake of simplicity, and then it will return an integer, and I'll show you why it will return one in here because else will return 0. So what does this return 0 and unspecified? We'll get to know in just a second. Okay, so we only want to execute a command as an application and a child process if this if it doesn't exist in this list, right? In this special list of commands, built-in commands. So you'll want to check for built-in commands. So for that, what we'll do is we'll check if a command entered is built-in command by doing if, and then built-in command, and then what's the argument? Okay, command with arguments. Argument. If it's equal to 0, then only we'll execute this, else we won't. Else we'll just else this will get executed, the parts built-in command will execute first get executed, and if it returns that in the built-in command doesn't exist, and if we get a 1, we'll know that a built-in command exists. So because since change directory is returning 1, we will know that to return 1 in the exit command. Well, because we'll just exit the entire program, so there's no point returning, right? If it's change directory, we return 1, and if it's any other function like help, then we'll return 1. Or maybe just okay, for sake of fun, let's create something else. Okay, let's set another one. List of command to equal so a custom hello command. Okay, so these 3 of course we rent f so there. Just create a new line and return 1 as usual. Okay. So here let's just make an executable. Okay. 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 20. We gave leave it. Enjoy. And we get it's associated with the switch statements. What's wrong? Options. So, okay, that's a typo. And we get an error. I guess we haven't put it as together with the age. It's wrong. Okay. Okay. Okay, finally. Hello. Okay. Getting an error. Still we're getting an error. Okay. So change directory works, but for some reason hello doesn't work. So let's just see what's wrong. Oh, wait. Why this doesn't work? So let's change directory. Of course it works. Why does the hello doesn't work? Hmm. Just count number of CMDs too. Let me check. Number of CMDs. Oh, my bad, my bad. Thanks for pointing it out. It saves a lot of time. Yeah, yeah, it's saving now. Mm, Pass and fix. It works fine, and I'm really happy with the result. Couldn't be happier with that. And with this, we are done with our 3-day workshop. Not a lot of people turned out, but okay, it was fun, and I guess it will be uploaded so a lot of people can see it later. And of course, uh, I believe uh, it will be helpful for quite a few people. And yeah, there's a lot of work that went into creating the repo and uh, this whole and just creating the shell in general. So yeah, please, if possible, collaborate in the project and help us make it a better project. And yeah, we are done, and that's it. Thanks for attending, guys. It was fun. It was a fun 3-day event. Goodbye.